Here's a question on digital SAT that has to do with a scatter plot showing a relationship between x and y for 9 data points. And it says a quadratic model for data set A can be written as y equals 0.04x squared minus 0.06x plus 6.57. The graph of this model is shown on the xy plane. The data point x equals 0 is found to be the result of a recording error. That's this one. That's 0, 12, by the way. X is 0, y is 12. It's an error. It's an outlier. You see how it's an outlier? And it was removed from the data set to create data set B consisting of consisting of it should be the remaining, I don't know why it looks like their remaining, 8 data points. A quadratic model for the data in data set B can be written as AX, that should be as y equals ax squared plus bx plus c, where a, b, and c are constants of the correct model. Okay, so one thing you can do, and it's going to take a while, but you can always just look at the points, put them in, make a quadratic regression. I did table, I put in all the points, made a quadratic regression. You can see it's approximately the same as the one mentioned. That's for A. This one is A. I don't think I can label it. And then I made another regression, but I didn't put in the 0.012. And you can see the A number is, it was originally 0.04, now it's 0.2, so it's bigger. The C number is smaller. And so is A bigger? Yes. Is C smaller? Yes. And that's answer choice C. However, I can also see this is an outlier above. That means it's pulling, notice though, the y-intercept is about 6.57. So this number 12 is pulling the y-intercept up. And if I remove it, the y-intercept will go down. So this constant term will go down, and that verifies that. And then if it's way up here, it's going to pull, let's say the parabola is here, and I put a point here. It's going to pull that vertex up. So it's going to make this thing get flatter. It's going to make it flatter and flatter and flatter. So if I get rid of it, it's going to allow this thing to get thinner again. In other words, it's going to make the A. And you have to know, if A is bigger, the parabola gets thinner. It goes up faster. So I will prove that on Desmos. Here is y equals 3x squared. See what that one looks like? And then I put y equals x squared. I made A bigger. See how it flattens it out? So a bigger A flattens it out. So A, I'm sorry, a smaller A flattens it out, not a bigger A. A bigger A makes it thinner. So since this thing, the vertex wouldn't be pulled up, it would allow this thing to be thinner, and that means the A would be bigger, and so that verifies that. So either you know it by the features of the parabola, or if worse comes to worse, just type in the approximate points and see. Is the number in front of x squared bigger? Yes. Is the number in front of, is the constant smaller? Yes. And that verifies it as well.